So, welcome to week 6. In week 6, we're going to try to cap this course off by doing a couple things that are a little bit unusual, a couple things that hopefully are good summaries and good recaps of the kinds of things that we've been thinking about. This first lecture is really a quick, breezy overview of the energy transformation system that we've been learning about in this course. We start, as is appropriate, with the idea that we get solar energy input. From this thin, very distant thermonuclear reactor, we get input of solar radiation, which comes into the Earth in different angles and different ways. Some of it is absorbed by the atmosphere, some of it is going to be reflected off the atmosphere, some of it penetrates all the way to the Earth's surface, where it causes a variety of effects, some of which is simply to be reflected. That reflected radiation, of course, can be bounced around in a variety of different ways as well. The solar energy, which is received by the Earth, warms the Earth. It causes a surface heating and a temperature change. That causes an emission of photons, but it also causes an evapotranspiration process to take place where we get a change in phase. And that change in phase we notice as being a cooling if we're wet, and that transfers energy from the surface of the Earth into the atmospheric system through that process of evaporation and transpiration. But of course, that's not the end of the process. As the air rises, it typically cools, and the cooling air invariably at some point produces a process of condensation. So we get a phase change back from, in this case, vapor form back into a liquid form, and sometimes directly into a solid form in ice crystals and pellets and snowflakes. And that process of condensation releases back to the atmosphere the same energy that was absorbed during the process of evaporation. Condensation, of course, isn't simply a separate phenomenon, but results in a coherent formulation of sort of larger structures, which we know as clouds. And those clouds, of course, are going to change this radiation input, both from the point of view of the radiation that comes into the Earth, but also from the radiation that's reflected and recycled through that process of different reflective and transmission processes. Clouds don't just form forever. There's a precipitation pattern that we just watched that, of course, drives the entire hydrologic cycle on the surface of the Earth and produces rainfall. This process is often unstable. The process of condensation and cloud formation leading to precipitation, that often leads to energy processes that are dozens or even hundreds of times more rapid than those of evaporation and transpiration, simply because this process tends to be stable, this process unstable. This process tends to run uphill and stops easily. This process tends to run downhill and quickly runs away from the original process. This heating is never uniform as a result of different textures, different surfaces, different angles, different latitudes, different seasons. We get differential heating, and differential heating acts through density and gravity effects to produce a preferential movement of air. That gravity acts down, but we get a process of thermals which allows transfer up. And this gives us our overall convective processes that lead to all sorts of interesting components, from cloud formations to thunderstorms, which can be sometimes dramatic, to hurricanes, which of course can be devastating in terms of their significance, to, of course, the surge effects that we learned as a result of the Ekman process. And, of course, we can also get the formation of tornadoes. Very high energetic processes that are fueled to a very large extent by this differential heating, this evapotranspiration process, all of which are storing solar energy and resulting in these cascades of energy, producing this dispersal and then recombination effect as a result of this overall process. Convection leads not only, of course, to rainfall and storm events, but to the overall wind and circulation patterns which characterize our planet, which characterize the major convective cells of our primary cells of the Hadley cell and the Ferrel cell and the polar cell, and then through Coriolis produce new kinds of convective effects and winds in things like the Walker cell, which is associated with the Southern Oscillation System and the El Nino effect, the so-called ENSO effects. The wind, of course, is not the end of it. We get different kinds of winds. We get local winds. That differential over a short period of time between day and night often produces a transfer. We get sea breezes that come off the sea in the daytime as a result of the differential heating and warm air being transferred back over the ocean, and where the process often reverses at night. And we get our global wind patterns as well, this overall convective pattern that produces wind effects. And of course, wind produces waves, and waves are part of this overall process that are taking place. And waves, of course, are also producing our various current, and all of these things are where we humans tap into these systems to produce energetic effects, whether they're hydro or wind or waves or currents. We're always tapping into these overall Earth's energy processes. It's an overall system of cascade and exchange and transfer, one of tremendous richness, of tremendous fascination, dynamic in time, in space, and of course one that humans pay attention to, both from the point of view of harvesting or drawing in these energies, and also from the potential of changing landforms and indeed changing the atmosphere with the contingent effects that that might bring in terms of global warming and climate change. The final end of the cascade is invariably that we end up with thermal energy. This produces, of course, an equivalent cascade of energy that's leaving the Earth that is closely balanced to the energy that comes in, where the Earth is primarily a kind of a giant change machine, that it takes high energy input in the form of high energy photons and spreads out into space low energy photons, many more of them, but the overall balance is close, although we get seasonal fluctuations and changes and potential accumulation. And that overall transfer process we've modeled here is that outflow of thermal energy in the form of low energy photons or long wave radiation associated with the Earth's radiative output